In the summer of 2021, the Danish research vessel Havila Harmony completed a multi-beam sonar survey in an area of the North Atlantic between the Faroe Islands and the southwestern coast of Norway at depths ranging from 400 to 700 meters. The mission's objective was to map with high resolution a region of the seabed that geological models indicated as an area of potential deposits of economically valuable minerals. However, when the ship's technicians processed the sonar data during the nights of the survey, profiles began to appear on the screens that did not correspond to any geological formation in the reference catalog that geologists use to interpret the North Atlantic seabed. What the sonar was showing were elongated silhouettes distributed in groups, with dimensions and proportions that took the specialists on board several days to identify with any known category. When they finally did, the conclusion was so unexpected that the team repeated the analysis 3 times before communicating it to the expedition's scientific coordinator. The silhouettes corresponded to the hulls of wooden ships, dozens of them, grouped in an area of the seabed that no known historical record of shipwrecks in the North Atlantic included as an area of significant sinkings. Like, subscribe, and share. Let's begin. The Vikings were the most advanced navigators of their time in the North Atlantic. Between the 8th and 11th centuries, Viking fleets from the Scandinavian Norse peoples crossed the North Atlantic in vessels built with naval technology that combined an extraordinarily precise understanding of hull hydrodynamics with an equally remarkable knowledge of ocean currents, prevailing winds, and celestial navigation in the absence of mechanical positioning instruments. The longships, or dragon ships, the cargo nar, and the war snekar were vessels between 20 and 35 meters long, constructed using shipbuilding techniques that allowed for sufficient structural flexibility to withstand North Atlantic storms, while maintaining a lightness that made it possible to transport them overland between river basins. The Vikings sailed to Iceland, Greenland, and North America, establishing colonies that predated Columbus's arrival in the Americas by several centuries, but they also sailed south and east, establishing trade routes that connected Scandinavia with the Byzantine Empire via the rivers of what is now Russia and Ukraine, and repeatedly crossing the North Sea and the English Channel in raids that left a permanent mark on the history of Western Europe. Viking expeditions involved multi-ship fleets sailing together, and losses during storms in the North Atlantic were frequent. The North Sea and the Northeast Atlantic, with their winter storms producing waves over 10 meters high and sustained winds exceeding 100 kilometers per hour, took a steady toll in ships and lives throughout the centuries of the Viking Age. Many of these sunken ships were never recorded in the sagas and chronicles that constitute the primary historical source for the period, as these texts tended to record the great expeditions and famous leaders, but not the routine sinkings of merchant ships or small exploration fleets. It is estimated that between the 8th and 12th centuries, between 50,000 and 100,000 vessels of various types were built in Scandinavia, and that a significant fraction of them ended up on the bottom of the North Atlantic or adjacent seas. The findings from the Havila Harmony expedition were initially presented to a small group of archaeologists specializing in medieval Norse culture from the universities of Bergen, Copenhagen, and Aarhus, who were invited to analyze the sonar data before the results were published. Analysis of the sonar profiles confirmed that the silhouettes corresponded to wooden vessels between 18 and 32 meters in length, consistent with the ranges of Viking ships documented in archaeological excavations at Roskilde in Denmark, where the Viking Ship Museum houses the remains of 5 11th century ships recovered from the bottom of Roskilde Fjord in the 1960s. The distribution of the ships on the seabed, in groups of 3 to 7, was consistent with the pattern of Viking fleets traveling in convoy for safety and mutual support, and suggested that several groups of ships had been sunk in separate events over undetermined periods of time. The state of preservation of the ships, estimated from the clarity of the sonar profiles and the height of their silhouettes above the seabed, was described by archaeologists as extraordinary for their estimated age. The depth at which the ships rest, between 400 and 700 meters, creates exceptional preservation conditions in the North Atlantic. The cold, oxygen-poor waters at these depths inhibit the activity of wood-boring organisms and slow down bacterial decomposition. Viking ships found in the shallow waters of Scandinavian fjords and harbors have shown levels of wood preservation that allow for the reconstruction of highly accurate construction details even after 1,000 years of submersion. The North Atlantic ships in deeper and colder waters could be in even better condition. Like, subscribe, and share. Definitive identification of the ships as Viking requires direct visual inspection with underwater vehicles, as sonar data, while detailed enough to establish the dimensions and general shape of the hulls, cannot provide information on the specific construction details that distinguish a Viking ship from a medieval vessel of another naval tradition. Medieval vessels from Northern Europe shared many general construction features, and only direct analysis of hull planking techniques, the type of wood used, and the details of the keel and frames allows for a reliable identification. The follow-up expedition, planned for the summer of 2023 but postponed due to funding issues until 2024, aimed to deploy the Bergen Institute of Marine Research's ROV to obtain the first direct images of the ships and collect wood samples for radiocarbon dating. Preliminary results from the 2024 expedition confirmed that at least 8 of the ships directly inspected exhibited construction features consistent with medieval Scandinavian naval tradition, including the clinker-built hull technique, in which hull planks overlap slightly rather than being joined edge to edge. This technique is characteristic of Scandinavian shipbuilding and distinguishes these ships from Mediterranean and Atlantic naval traditions of the same period. The ship's timbers, although weakened by time and submerged conditions, retained enough structure for the team's dendrochronologist to obtain samples for analysis. Radiocarbon dating of the first samples indicated timber felling dates between 850 and 1100 CE, a range that corresponds precisely to the period of greatest Viking naval activity in the North Atlantic. The discovery has historical implications that extend far beyond naval archaeology. The presence of a Viking ship graveyard in that specific area of the North Atlantic suggests that regular shipping routes existed between Scandinavia and the North Atlantic islands, possibly as far as Iceland and the Faroe Islands, involving crossing deep ocean areas much more frequently than available historical records suggest. Icelandic sagas mention catastrophic storms that sank entire fleets in the North Atlantic, but the geographical details of those narratives are difficult to reconcile with modern maps because the place names and descriptions of sailing directions in the sagas cannot be directly translated into current geographical coordinates. The North Atlantic ship graveyard could be physical evidence of one or more of those catastrophic events mentioned in the sagas. The Viking Ship Museum in Oslo, which houses the world's 3 best-preserved Viking ships recovered from the Gokstad, Oseberg, and Thun burial mounds in the 19th century, has expressed formal interest in collaborating on the underwater graveyard investigation. Its researchers point out that studying Viking ships in the context of an actual shipwreck, with the original distribution of cargo and crew belongings as they were left at the time of sinking, is archaeologically far more informative than the ships from the burial mounds, which were deliberately prepared as grave goods following rituals that altered the original arrangement of objects. A ship sunk in a storm is a record of the precise moment of sinking, a frozen snapshot of daily life on board that no burial excavation can provide. The Viking ship graveyard in the North Atlantic is one of the most significant underwater archaeological discoveries of the first half of the 21st century. Its systematic exploration, which will take decades given the number of ships involved and the depth at which they lie, promises to transform our understanding of Viking naval history and Atlantic shipping routes in the Middle Ages. Each ship directly inspected will add new data about the naval technology, trade patterns, and communication networks of a civilization that dominated the seas of Northern Europe for 3 centuries and left its mark from Istanbul to Newfoundland. The geopolitical and legal context of the discovery also deserves attention. Shipwrecks in the international Atlantic, outside the exclusive economic zones of coastal states, fall under a complex legal regime defined by the United Nations Convention on the Law of the Sea and the 2001 UNESCO Convention on the Protection of the Underwater Cultural Heritage. The latter convention stipulates that archaeological objects and underwater cultural heritage older than 100 years must be preserved and protected in situ, and that any activity affecting them must be carried out in accordance with principles of responsible scientific archaeology. The practical application of these principles to a ship graveyard in international waters at a depth of 400–700 meters presents logistical and legal challenges that the researchers involved are working with Danish and Norwegian authorities and UNESCO to resolve before systematic exploration expeditions begin. The technology available for exploring this ship graveyard has advanced enormously in recent years. Deep-sea ROVs like the Aegir 6000 from the Bergen Marine Research Institute, capable of operating at depths of up to 6,000 meters with high-precision articulated arms and state-of-the-art lighting and camera systems, are perfectly capable of carrying out detailed inspections of the ships without any damaging physical contact with the structures. Underwater photogrammetry systems allow for the creation of high-resolution, three-dimensional models of the hulls with millimeter accuracy from thousands of photographs taken from multiple angles, generating permanent digital records that preserve virtually every detail of the ships even as their physical condition continues to deteriorate. And non-invasive sediment analysis systems allow for obtaining information about the contents of the ship's holds without physical disturbance, detecting the presence of metals, organic materials, and other substances of archaeological interest in the surrounding sediment. With that technology, the exploration of the North Atlantic Viking Cemetery could produce one of the most comprehensive archaeological databases on medieval navigation ever assembled. The significance of this discovery transcends archaeology, touching upon the history of medieval North Atlantic trade routes. Viking ships were not merely instruments of war and plunder, as popular narratives often portray them. The majority of Viking maritime traffic was commercial. Cargo nar transported timber, furs, leather, beeswax, Baltic amber, slaves, and agricultural products between Scandinavian ports, the North Atlantic islands, the British Isles, and the markets of the Rhineland and the French coast. If the ships in the Atlantic graveyard include nar laden with goods, analyzing that cargo could provide direct insights into the long-distance trade patterns that connected the Viking economy to medieval European markets, a dimension of Viking history that written sources only describe in fragmentary and indirect ways. Like, subscribe, and share. See you next time.